Okay, so this is a rather long problem that deals with rate of changes, but it's a very important question. It has three parts, okay? Now let's tackle the first part, okay? Now let's say we have a right circular cone, and right now it's full of water or liquid. Now suppose the liquid is flowing out of the cone. So right here is leaking out water, okay? At this rate, okay? Now let the height of the liquid be HCM and the radius of the surface be RCM, okay? Now what we need to do is we need to prove this relationship, okay? Now this first part is extremely easy. What we need to do is basically look at the relationship using pretty much a similar triangle, okay? Now if this is 100 cm, this is 40 cm. Now if we keep leaking out of water, this part will be your H, right? Your water level, okay? Your height of the water, and this part is also your R, right? Okay, so as you can see, this is basically a similar triangle. Okay, so due to similar triangles, okay, we have R over H, okay, equals to 40 over 100, right? So R over H equals to 40 over 100. And easily, that will give us this result, okay? Okay, now, so the second part. We want to prove that the volume of the solution, okay, the waters in here, can be found by this expression, okay? Now, first of all, what is the volume of a circular cone? Well, if you still remember the formula, so V equals to 1 over 3 pi R square H in this case, okay? But there are a lot of things that we can substitute. Now, our target is to come up with this expression, okay? If you notice that there's no R in here, so we have to find a way to substitute R in here in terms of H, so that we'll be able to have an expression with H only, right? But we know that from part A, if you still remember, we know that R equals to this, right? So allow me to rewrite this again. V equals to 1 over 3 pi R square H, okay? And that equals to 1 over 3 pi, and we use it in here, and that's 2 over 5 H whole square times H, okay? And after you simplify everything, for sure you get V equals to 4 over 75 pi H cubed. Okay? So far these two parts are very simple. Okay? Okay, so now comes the crux of this problem. Okay, in part B it says, if the height of the liquid inside the container is 50 cm, what exactly is the rate of decrease in the liquid level? Okay, now the hardest part is to identify in algebra what exactly this is referring to, okay? Let's go to this term by term, okay? Now, first thing, what exactly is the problem asking you to look for? It's asking you to the rate of decrease, right? That is the rate of change. Rate of change, that means it must be d something and dt, right? Because it's a speed out of some time, right? Okay? d something dt, okay? That's an indicator. Now, that's the rate of change in what? Liquid level. What is liquid level? Well, liquid level basically, as you know, is talking about how the water level, which is H, right? The higher the level is, the bigger the H is, right? Okay? So you have to first identify and know that the problem is asking you for dH dt. Okay? It's asking you for this. Okay? Now, what other information do we have? Look at this. If the height of the liquid inside the container is 50 cm, so we're talking about the H, right? The height. That is the liquid level, the water level. So you know that H equals to 50 at some point in time, right? Now what else? Let's see. The liquid is flowing out of the cone at a rate of 5 cm cube per minute. Okay? Remember, we're leaking out water, right? And that's the volume of water, right? We're losing water from time to time. Okay? So this 5 cm cube, okay, if you look at this, some sort of volume, right? It has to be related to V, right? But we're talking about a rate. The rate of V per minute. Per minute, that must be time, right? T, right? Okay? So if you put them all together, and if you let T be the time, okay, then this must be talking about dV dt, okay? So there must be another quantity, T, okay? It wasn't declared, so we write this out. We declare it. Let T minutes be the time that the liquid has been flowing out, okay? And again, and some other information. We know that dV dt equals to -5, okay? So how do you put all these together? How do you put all these together, okay? Well, we have to go back to our main variable. That's V, right? Okay, how do you go from V, how do you relate these two together? That is what exactly we're learning in this chapter. Okay, so how do you go from here to here? Okay, well, then you are missing this part. Okay, it's almost like, it's not exactly a fraction, but it's almost like a fraction where you can cancel this and you get dV dt, okay, in a sense. All right, so what about dV dH? How do you find dV dH? Well, basically you have an original expression. Remember, we did this in our previous part. How do you find dV dH? You find the derivative of this, right? You take the derivative of this, then you can find dV dH. Okay? So let's put them all together. Okay? So that's how we start. We let this, so we declare a new variable we call t in terms of time, okay? And we start with this chain rule relationship, okay? Now, dV dt, notice that I've put all my information here, right? So dV dt is just -5, okay? Now, dV dH, dV dH is when I take the derivative of this. So that is 4 over 25 pi h squared. Okay? And dh dt is exactly what we're trying to find here. Okay? And then let's continue. Okay? Negative 5, 4 over 25 pi. Now we know that h is 50, right? So I'm going to put 50 squared dh dt. Okay? So after doing all these, you will find out that dh dt equals to negative 1 over 80 pi. Well, that is not finished. Remember that we're being asked for the rate of decrease. Rate of decrease. Okay? And so certainly our answer is negative, right? And that shows that, that tells us that it is indeed decreasing. Well, think about this, because we're losing water, right? So your water level must start going down, right? Okay, and so that makes sense. Okay? So how do you answer the question? So therefore, the rate of decrease is, when you talk about the rate of decrease, your answer will never be a negative, right? If it's negative, then it's increasing, right? So this is what you write. 1 over 80 pi. Now, what is the unit? Well, h is a length, right? So it must be cm per something. What is your unit of time? Minute. Okay? So this is what we do here.